Okay, question 7. Simple model for the value of a car depending on its age. Its value when new is £20,000 and after a year it goes down to £16,000. It wants us to use an exponential model. So models are exponential when they're in the following form. So its value is equal to the initial value times by some multiplier. So let's say k to the power of the time. You could use e. You could alternatively you could have said some other a value. So let's call it a1 times e to the power of kt. K's obviously aren't going to be the same. That would work as well, but for this particular question, it's simpler if we just use k rather than e to the k, because there's no suggestion that e's or logs are going to be helpful here. So I'll just get rid of that, and then the starting value is always this a value here, but we can do that properly if we look at what happens when t is 0. We know the value needs to be 20,000. And if we substituted that in, we'd get a times k to the power of 0. And k to the power of 0 is 1, so that shows us that a is 20,000. But that's always true. A will always be the starting value of the car, or the starting value of the growth of bacteria, or whatever the question chooses to use as the context. So we've got v equals 20,000 times some multiplier to the power of t. Now this, in this case, is going to be the rate at which the car is depreciating, because it's losing value. So simplest way to work that out in general is to look at what happens when t is 1 now, because we know when t is 1 the value is 16,000. And if we substitute that in, we can solve for k. So 16,000 divided by 20,000 is going to equal k to the power of t, but t is just 1, so that's just k. So k is 16 over 20, or 4/5. So the equation that we're going to use is v is 20,000 times by 4/5, or 0.8 to the power of t. Okay, it says then that the car is monitored, the value of the car is monitored over 10 years. The value after 10 years is £2,000. So let's have a look at what our model thinks the car will be worth after 10 years. So when t is 10, the value is going to be 20,000 times 0.8 to the power of 10. So that comes out at £2,147.48. I think that's a fairly decent model. If you compare the difference, that's about it's less than 10% error. It's about a 7 or 8% error, which I think is fairly decent over 10 years. So I would say that the model is reliable. Since that 2,147 is close to the actual value after 10 years. It then says we've got another car B that has the same starting value, so it's going to start with £20,000, but the K value is going to change because it says it depreciates more slowly, which means we're not going to be multiplying by as much each time. It's still going to decrease though. So to make it decrease but slower, the 0.8 that we had earlier is going to get closer to 1 but never actually equal 1. So we can adapt the equation by increasing the value of k so that it is greater than 0.8 but less than 1 still. So k will be somewhere between 0.8 and 1.